Welcome to The Explainer, where we literally engineer the perfect DNA of an answer for Cambridge AS and A-Level Computer Science 9618. Today, we're targeting the notoriously difficult third normal form, or 3NF. I'm your host, and my mission today is to act as your strategic geneticist. Look, we aren't just going to sit here and read textbook definitions. No way! We're going to splice together the absolute perfect A-star level exam response. Think of it this way. Evidence plus analysis equals an A-star. Whether you're transitioning from IGCSE syllabuses like 0417, 0478, 0983, 0984, or O-Level 2210, or you're diving straight into the deep end of 9618, the logical foundations you need are exactly the same. You know what a database is, you know what a table is. But the way you articulate that logic to the strict Cambridge examiners, that is an entirely different beast. Let's get right to work.
Okay, listen to this incredibly revealing quote straight from the principal examiner reports. They literally wrote, "Normalization, third normal form, is one of the most misunderstood areas in computer science." Let's fix that right now. Now, when examiners say misunderstood, they don't necessarily mean that you don't know what a primary key is. They mean that candidates completely and utterly misunderstand what the examiners actually want to see on the page. You've probably been there, right? You walk out of the exam hall thinking, yes, I nailed that database question, only to find out later you lost 60% of the marks. Why does that happen? Because the assessment framework prioritizes analytical depth over superficial breadth. You can memorize the definition of a transitive dependency all day long, but if you cannot apply it to the specific, messy, completely unnormalized data table they drop in front of you, you will not get the marks. It's really that simple.
So here is our strategic masterclass agenda. First, the 3NF examination trap. Second, decoding the method mark strategy. Third, the examiner warning list. And finally, the blueprint for top marks. Section 1. The 3NF examination trap. Let's look at the classic traps by examining two hypothetical students who represent the most common pitfalls we see in computer science papers year after year. First up, we have Alex. Now, Alex sits down in the exam hall, sees the word 3NF, panics with joy, and immediately brain dumps every single textbook fact about first, second, and third normal form right onto the page. Alex writes beautifully about atomic values, partial dependencies, and non-key attributes depending on other non-key attributes. It's basically a textbook. But guess what? Alex scores barely anything. Why? Because Alex overloaded the answer with raw facts, but offered zero analysis linking back to the provided database scenario. The examiner honestly doesn't care if you know the dictionary definition. They care if you can spot the actual problem in the given customer orders table. Then, on the flip side, we have Sam. Sam is a fast worker. Sam rushes straight through to the final normalized tables, completely ignoring the command word requirements. Sam misses absolutely crucial edge cases, like a composite primary key that was subtly hinted at in the question text. And worst of all, Sam dropped all the working out. As a result, when Sam makes one tiny error in the final table structure, there are 0 marks awarded, because there's absolutely no evidence of the logical process. So Alex loses points for lacking context, while Sam drops marks for missing boundary conditions. Raw facts without application will sink your grade every single time.
Moving on to Section 2, decoding the method mark strategy. This is where we learn how to turn those red pen marks into green check marks.
To fix flawed answers like Alex's and Sam's, we need to understand how the grading actually works behind closed doors. The method mark strategy dictates that marks are awarded for the procedural process, the logical steps, and the systematic analysis, rather than just your final answer. The assessment framework heavily prioritizes analytical depth. This means you get method marks for your algorithmic thinking. Think of your exam answer as a piece of code. You wouldn't just write the output. You need step-by-step decomposition. You need to show your clear working, even if your final resulting tables are slightly off. If you can show the examiner that you successfully identified the transitive dependency, isolated it, and created a new relational table with a foreign key, even if you messed up the naming convention slightly, you are securing method marks. It's a standardized sequence. Identify key elements, apply relevant principles, execute the analysis with clear working, and verify the result. Before we solve why these multi-step 3NF calculations cost so many students their grades, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so why do students find multi-step calculations so impossibly hard? Well, it's because our brains naturally want to jump straight to the finish line. The real culprit is the lack of a structured communication framework. Students can often see the right answer in their head, but they completely fail to document the journey to get there.
Let's fix that right now. The absolute secret to securing those elusive method marks is the PEAL framework. Point, evidence, explanation, link.
Let's break this down for a 3NF computer science question like we're in a live workshop. Your point is identifying the specific issue. For example, you write, the table is not in 3NF due to a transitive dependency. Next, your evidence. This must be extracted directly from the exam paper. Don't make it up. Specifically, the attribute nurse name is dependent on nurse ID, which is not the primary key of the patient table. Then, your explanation. This is the algorithmic step you are taking to fix the broken database. To resolve this, a new table named nurse must be created containing nurse ID as the primary key and nurse name, leaving nurse ID as a foreign key in the patient table. Finally, the link. This ties it all back to the core concept. This ensures that all non-key attributes are only dependent on the primary key, satisfying the rules of 3NF. Boom! That structure ensures every single point you make is backed by hard evidence and inextricably linked back to the specific context. It literally forces you to show you're working.
Section 3. The Examiner Warning List. Now that we have the Peel framework, let's get the exclusive inside scoop on what examiners explicitly warn against when grading these normalization questions. The principal examiner reports reveal these 3 critical mistakes. Mistake number 1, and oh, this one hurts to see, vague technical details. Using phrases like, I will separate the tables so there's no repeating. Listen, that is IGCSE level language, maybe. At AS and A level 9618, you must use precise theoretical definitions. You need to be saying, I will remove the partial dependency to achieve 2NF. Mistake number 2, forgetting boundary conditions and edge cases. In databases, this often means completely ignoring what happens if a patient has multiple appointments on the exact same day. Do you need a composite key? Students rush, just like Sam did earlier, and miss these edge cases entirely. Mistake number 3, and this is the absolute classic. Answers not specific to the question context. If the exam question is about a veterinary clinic and your perfectly written paragraph doesn't mention animals, vets, or treatments, you are writing a generic answer, and you will lose the marks.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now, back to the strategy. This comparison perfectly illustrates the exact difference between losing marks and gaining them. Look at the generic answer. 3NF removes transitive dependencies. Sure, it's a true statement, but that gets 0 application marks. Now look at the context-linked answer. Removing the transitive dependency between patient ID and ward nurse ensures 3NF. That single sentence proves to the examiner that you understand the theory and you've actually read the data provided in the paper. You've applied the methodology. This is exactly how you engineer the DNA of a top-tier response.
Section 4. Blueprint for top marks. Let's apply our strategy and execute the procedural framework that builds the perfect A-star answer.
When tackling 9618 3NF questions, you've got to systematically process the problem. Imagine you're in an interactive workshop right now, timer ticking down. You follow this exact 5-step standardized sequence. Step 1, deconstruct the question. What is the command word? Is it describe, explain, or normalize? They all require entirely different depths of response. Step 2, extract relevant data. Imagine a complex data table right in front of you. You've got 60 seconds. You mentally scan the data. Your eyes should immediately dart to repeating groups of data. That is always your first clue. Step 3, select the analytical framework. We know it's PHEL. We know we need to go logically from 1NF to 2NF and finally to 3NF. Step 4, execute with clear notation. This means drawing clear tables, underlining your primary keys with a solid, undeniable line, and using a dashed line or an asterisk for foreign keys, depending on the specific notation the question requested. Step 5, present with terminology. This is the speed writing phase. Ask yourself, if you had 30 seconds to speed write a Peel paragraph right now, would it contain at least 3 technical terms? You need words like entity, attribute, relationship, composite key, and transitive dependency. If your paragraph doesn't contain these, you simply aren't hitting the rigorous standards of the mark scheme.
So look closely at your own exam practice. Think about it. What happens when the paper asks you to evaluate alternatives or compare different database approaches? Can you identify the missing evaluative step in your 3NF analysis? Many students can perform the mechanical, step-by-step normalization, but they absolutely freeze when asked to justify it. Problem-solving in computer science uses a deconstruct, solve, evaluate methodology, checking for reasonableness and making justified recommendations. That is what separates the A students from the A-star students.
Notice how top-scoring candidates use a matrix of evaluative requirements to execute higher-order assessment objectives. Let's say the requirement is to discuss trade-offs. Top students don't just say 3NF is great. No, they analyze the limitations. They might say, while 3NF radically reduces data redundancy and prevents update anomalies, it can actually lead to slower read performance because the database has to perform complex joins across multiple tables to retrieve a single complete record. Wow, that is an A-star evaluation right there. You absolutely must utilize comparative connectives, words like whereas, however, conversely. And you must draw cross-topic connections. Examiners explicitly reward this. Linking normalization back to file organization, or network speeds, or database security shows a holistic, massive picture understanding of the entire 9618 syllabus.
Let's bring this all together. A contextualized 3NF answer is an engineered response where precise theoretical definitions are inextricably bound to context-specific data and causal relationships. Remember our geneticist metaphor? This is what we mean by engineering the perfect DNA of an answer. You are carefully fusing the theoretical architecture, the textbook rules, with precise scenario-based evidence to create a totally bulletproof response. It is logical, structured reasoning. Every single sentence you write should serve a specific purpose. Either you are stating a technical fact, providing evidence from the source text, explaining the algorithmic step to fix the problem, or linking it back to the exam question. There is zero room for fluff.
To recap your masterclass blueprint, here is the final cheat sheet system that guarantees top marks if you follow it religiously. Rule 1. Always decode the command words first. Rule 2. Rigorously apply the Peel framework to secure every single one of your method marks. Rule 3. Use the deconstruct, solve, evaluate methodology, especially for those heavy, higher-order questions that require an analysis of trade-offs. Rule 4. Never, ever leave your answer generic. Link absolutely all points back to the scenario. Listen closely. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by.
Before we wrap up this explainer, I want you to really look at your most recent past paper attempt. Are you acting like Alex, just frantically dumping facts onto the page? Or are you acting like the strategist, engineering a highly contextualized, bulletproof response? Normalization isn't just an exam hurdle you have to jump over. It is the fundamental architecture of the data-driven world around us. Master it here, and you master the logic of modern software. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.